This is the compound particles remediation for students that weren't in class when I actually did that short lesson. There were 3 questions in the test that students tended to struggle with. The first one has to do with figuring out how we can tell whether a chemical change has happened or not. So I'm just going to list those factors that could prove a chemical change happens. Doesn't mean that if these things happen, there was definitely a chemical change. And all of these factors are things that you can observe. Number 1, color change. Number 2, formation of gas, which you might see as bubbles. Number 3 would be release or absorption of energy. And number 4 would be making a precipitate. Those are the 4 observations that could tell you that a chemical change is happening. And in the test, there was a question that had lots of different options, but you only wanted to choose options from this list that is over here. So in the video I'm going to play now, you can see that we get a color change, and you can also see that there is bubbles, there's a formation of gas. If I had to measure the temperature, it would be getting warm, but you can't actually observe that. And you definitely can't observe particles coming together to make a compound. You can't see a new compound forming in front of your eyes. You can see an observation that might tell you that, but watch this video and look for the color change that's definitely happening and the formation of gas. The next question I want to look at was about the reaction between hydrogen and oxygen to produce water. In fact, this was the worst question out of all of my classes. And we can see that the ratio of hydrogen to oxygen in water is 2 to 1. So the question said that twice as much hydrogen combines with oxygen to make the formula H2O. It said, what happens if you had equal volumes of hydrogen and oxygen reacting? And there was a video that you guys did on Edpuzzle where they put some O2 and they put some H2, equal volumes. They kind of all got mixed up, and when those two reacted, there was some oxygen left over. And that's because twice as much hydrogen is needed as oxygen. Just because you've got equal volumes of hydrogen and oxygen reacting doesn't mean that you're going to get a compound forming with a new formula. The law of definite proportions says that the ratio of different elements in a compound is fixed. No matter whether you have lots of one element reacting with a little bit of another, or if you have equal volumes. So you're always going to make H2O. It doesn't matter how much hydrogen and oxygen you're causing to react. And then the last question I want to look at has to do with a comparison between air and pure oxygen. So if we look at air, air is made up of a number of different gases. There is oxygen in air, so I'm going to draw some oxygen molecules. But most of the air is actually nitrogen. So there's a lot more nitrogen molecules than oxygen molecules. And obviously in air we've also got some carbon dioxide. I'm just going to draw one molecule because we don't have a huge amount of carbon dioxide, but it is there. So you can clearly see air is a mixture, and we've got molecules. That's what it's made of. Now if we looked at pure oxygen only would have one kind of particle. But those particles are still molecules. It's not a mixture anymore, it's an element. So we have an element here, we have a mixture over there, and in the question that people struggled with, you had to correctly compare air and pure oxygen. So they're both made of molecules. One happens to be a mixture, one happens to be an element, and I hope that helps with any of you that have to still do the retest.